Welcome back to physics class. Children, in today's class we will solve problems based on electric power. And let us start with the first question. A radio set of 60 watts runs for 50 hours. How much electrical energy is consumed? So children, when we say that is power means, what the formula should come in our mind? V into I, isn't it? One formula. Then similarly V square divided by R has to come in our mind. Then energy formula E is equals to what? P into T. All these formulas should come in our mind. The first thing is, what are the given data, children? P is equals to 60 watts. Because they are saying that a radio set of 60 watts runs for 50 hours. Means the power it has consumed how much, children? In terms of a watt, they have given it as a 60 watts. And the duration for this is what? Timing is what? 50 hours. Isn't it? And what they asked us to calculate, that is E is equals to energy. Electrical consumption is equals to how much? We know, children, we know that the commercial unit of energy, commercial unit of energy, that is kilowatt hour is the commercial unit of energy. And in terms of SI unit, how we will write? Also SI unit of energy is what? 1 kilowatt hour is equals to 3.6 into 10 to the power of 6 joules. Isn't it, children? Joule is the SI unit of energy. So 1 kilowatt hour is nothing but here 3.6 into 10 to the power of 6 joules. Here the P value, power is given in watts. So in order to get the commercial unit kilowatt hour means we need to convert this power in terms of kilowatts. So 60 divided by 1000 we can write, isn't it? You may ask how this 1000 comes, because kilo is nothing but 10 to the power of minus 3, isn't it, children? So 60 divided by 1000 is equals to 0.06 what? Kilowatt. So now what we did, we have converted watts into kilowatts. What the value we got, children? 0.06 kilowatts, isn't it? Now, is there any need of a conversion of a time? No, because they have directly given in a hour, so no need of a converting here. Now we will use the formula E is equals to P into T. This implies, children, E is same as it is. What is the P value? 0.06 kilowatts into, what is the time value? 50 hours. So then 0, then 3.0, or you can write 3 kilowatt. Kilowatt into hours multiplied means kilowatt hour. This is what? The commercial unit of energy, isn't it? 3 kilowatt hour is what? Electrical consumption in terms of a unit or the commercial unit. Now, if we convert this in terms of a joule, also in terms of joule, we have to multiply this with 3.6 into 10 to the power of 6 joules, children. That is, if 1 kilowatt hour is equals to 3.6 into 10 to the power of 6 joules means 3 kilowatt hour is equals to 3.6 into 10 to the power of 6 joules into 3 kilowatt hour, isn't it, children? So what is the value? That is here better I will write here 8, then 10 and S, 9 plus 1 10 into what has left 10 to the power of 6 joule. isn't it, children? This is what in terms of a joule. Suppose if you are converting in terms of a SI unit of a energy means this formula you have to write. Suppose if you are writing in terms of a unit or commercial unit of energy means this kilowatt hour units we have to use. It's a very simple, children. Only the thing is you have to think whether what they have given. Suppose if they have given power in terms of a watt means first convert it into kilowatts, and if they have given duration in terms of a seconds or minutes means you have to convert it in hours. Then you have to go for solving using the formula electrical consumption E is equals to power into time. Now after substituting the values we will get a energy in terms of a kilowatt hour. Got it, children? We'll solve one more problem. That is, a current of 4 amperes flows through a 12 volts car headlights bulb for 10 minutes. Means here the current, how much amperes is flowing, children? 4 amperes of a current is flowing across the headlights of a headlight bulbs of a car here. Have a voltage, how much? 12 volts for 10 minutes. How much energy will transfer occurs during this time? So first thing what we want to calculate, first power consumption we want to know. So in order to get a P means we have to use now the formula V into I, because the variables voltage has given and the current has given, isn't it, children? Using this that is I and a V, we need to calculate first power value. After getting that power, it has to be converted to kilowatts, isn't it, children? Now here minutes is there. So what we want commercial unit in terms of hours, we have to convert these minutes into hours, isn't it, children? Okay, let me try step by step, children. That is, given current I is equals to 4 amperes, then voltage V is equals to 12 volts and time is equals to 10 minutes, which is equals to 10 divided by 60, isn't it, children? 60 hours, which is nothing but a 1 by 6 hours is what? Duration in terms of hours. Even you can multiply, that is even you can divide still, but I feel it's a better up to there. Okay, next, how much energy transfer means this is what we want to calculate. So first power consumed, P is equals to V into I, because formula this is, you can write here. What is the P value? Don't know. V is 12 volts into I is 4 amperes. So 12 for the 48 watts is the power, isn't it, children? See here, this is in terms of watts. We want in terms of kilowatts, which is nothing but a 1. Here you can write, this implies P is equals to 48 divided by 1000 kilowatts, isn't it, children? In terms of a kilowatts, we have to divide it by 1000. So we did. Now what we want, energy, that is E is equals to P into T, isn't it, children? What is this? This is energy consumption or transfer. You can write E is equals to, what is P value? 48 divided by 1000 into, what is the T value? That is in terms of hours, 1 by 6 hours. So when we do cancellation, that is 6 ones are 6 8s are, isn't it? 8 divided by 1000, which is nothing but a 0.008 kilowatt hour. Therefore kilowatt hour energy consumption or transfer, how much? 0.08 kilowatt hour is the energy transferred in 10 minutes of a duration. Nothing but 1/6 hours of a time. This much of energy it has consumed, children. Got it, children? Okay. Problem, that is, calculate the energy transferred by a 5 amperes current flowing through a resistor of 2 ohms for 30 minutes. Here they have given current value and resistance value. They asked us to calculate the electrical energy E value. So in order to find that E, first we want to know power consumption there. So children, so if current variable and resistance variable values given means we have to use their formula, P is equals to I square into R. With that formula, first we have to calculate what, children? P value given I is equals to 5 amperes, then resistance R is equals to 2 ohms, then time is equals to 30 hours, which is nothing but 30 minutes is there, 30 minutes, 30 divided by 60 hours, which is nothing but 0.5 hours. What is the T value, children? 0.5 hours. Got it, children? This is what? 60. Okay, now using formula, P is equals to I square into R implies P as it is. What is the I value? 5 square into R is 2. So 25 into 2, nothing but 50 watts. This is what in terms of watts. We want in terms of kilowatts. So P is equals to 50 divided by 1000 kilowatts. Therefore, P is equals to 0.05 kilowatts is the power value, isn't it? Even you can multiply, that is divide. Now, what we want? E is equals to P into T. So, what is the value of a P? 0.05 kilowatts into 0.5 hours, which is nothing but 5 is 25.025 kilowatt hour is the energy in terms of a kilowatt hour. Even with this value, you can even convert for a joule also. Got it, children? In terms of a commercial unit, how much energy consumed here? 0.025 kilowatts of energy has consumed. Now the question comes, a refrigerator having a power rating of 350 watts operate for a 10 hour a day. Calculate the cost of energy to operate it for 30 days, and the rate of electrical energy is rupees 3.40 per kilowatt hour. So children, after reading this question, we come to know that the power has given, isn't it? That is what in terms of watts, and the duration has given it 10 hour for a day, means per day, a single day it is working how many hours? 10 hours. But we want to calculate the cost of energy for 30 days. In a month, 30 days we want to calculate first. Then we with that value we have to multiply this rupees. Then we, definitely what we will get, that is cost of the 3.40 into kilowatt hour, isn't it? We will get the answer. So given P is equals to 350 watts. So if we convert this in terms of a kilowatts, means 350 divided by 1000, which is nothing but a 0.35 kilowatt. Then time has given 10 hours. So for a month of 30 days means T is equals to 10 hour into 30 days, isn't it? Which is equals to T is what? 300 hours. Means in a month this much hours it is working. Now what we want to calculate? E value. E is equals to P into T. So what is the P value? 0.35 into 300 hour. So then 3 5s are 15, isn't it? 3 3s are 9 and plus 1 10 and 0.00 kilowatt hour. This is what energy. We can write directly it as a 105 kilowatt hour is the energy consumption. That is electrical energy consumed for 30 days is what? 105 kWh. Suppose this is what, children, the cost, how much they have given. If the cost of electrical energy, that is E is equals to, what is the cost? 3.40 rupees into, what is the energy value, children? That is 105 kWh. So which is nothing but, children, 105 3.40 into 105. Here you can take what means 3.40 into 105. 0 5 4s are 20. 5 3s are 15, 16, 17 plus 0 0 0, then 0 4 3. You will get 753 and 2 digits after point. So 357 is the cost for 30 days. 357 rupees. So the cost for 30 days is equals to 357 rupees. Isn't it, children? It's a very simple. First we have to convert, that is power value in terms of a kilowatts. After that, time they have given it for 10 hours a day, means we want to calculate its cost for 30 days. So multiply, we will get a time value using the energy formula. We will get a, that is kilowatt hour. Suppose if the cost of 1 kilowatt hour is what? 3.40. Even you can write here, that is 3.40 rupees. Then what is for 30 days? Means what is the energy consumption? Means we have to multiply with the given rupees. Then we will get the cost for 30 days. That is what? 357 rupees is what here? The cost of the energy what they have used for a complete 30 days to calculate resistance. And also 5 such bulbs, if they are burned for 4 hours, they asked us to calculate energy consumption. Here there is E value, and after getting the E value we have to multiply with the cost. Then we will get in terms of rupees, children. So first what we have to do, we have to find P value. That is given is what? V is equals to 200 volts. Then P is equals to 100 watts and R is equals to how much? Then T, isn't it? T is what? 4 hours. This is what? For one bulb, isn't it, children? That is using formula P is equals to V square divided by R implies 100 watts, which is nothing but a 200 whole square divided by R. R is nothing but a 200 into 200 divided by 100, 0. Then what is that? 400 ohms is the value of a resistance. Got it, children? Now we have to find what? That is the cost of or the electrical energy. First let us calculate. E is equals to P into T, isn't it? So 100 divided by 1000 into, that is what? 4. These two get cancels. 4 divided by 10, that is what? 0.4 kilowatt hour is the energy of one bulb, isn't it, children? So energy of one bulb is 0.4 kWh. Suppose in the question they said that 5 such bulbs are connected, means suppose 5 bulbs means we have to multiply 0.04 into 5, which is nothing but a 20, isn't it? 2.0 kWh is what? That is for 5 bulbs. Even you can write this here. E is what? 2 kWh is the energy of 5 bulbs. Energy or electrical energy consumption for each bulb is 0.4 kWh, whereas for 5 bulbs means 2 kWh is the energy consumption. Suppose the cost of 1 kWh is, the cost of 1 kWh is equals to, what is the rate, children? 4.60 per unit. Then what is that? For 2 kWh, what will be the cost? 4.60 into 2 kWh, which is equals to 2, then 8 plus 1, 9. Isn't it, children? 9.20 rupees is the cost, isn't it? So you can write here, what is the rupees value? 9.2 kWh is what? The rupees, isn't it? 20 is the value. Got it, children?